Over the years, I've been asked on many occasions, what is the maximum ambient temperature that I can use the power supply to? That question in itself needs to be addressed fully. When we design a power supply, we develop a derating curve along with that. And the derating curve is in line with our design policies. And our design policies do not allow any component go beyond 80% of its designed maximum temperature. So for example, for a FET, the maximum junction temperature is 150 degrees. Because we cannot measure the junction temperature directly, we measure the case temperature. We apply a thermal resistance calculation, and from that then we can decide what the maximum junction temperature is in the application. So derating by 20% sets the maximum ambient in which it can be used. This is repeated for not just FETs, it's repeated for diodes, for capacitors, for PCBs, for all components on board. And from that then we will develop our own derating curve. The example I show here is the 48 volt power mod, which is designed to operate up to 200 watts, up to 40 degrees Celsius, and then we derate from 200 watts down to 100 watts between 40 degrees ambient and 70 degrees ambient. So what's the limiting factor on that? Well, the limiting factor on that is how hot the individual components get. On the CoolX 600, we do not have a fan. So you can get the full 200 watts out of this device up to 40 degrees ambient without the need for external cooling. But what happens if you do decide to apply either external cooling or attach it to a base plate by some of these pre-drilled screws for you to use? Well, the effect will be, if you attach it to a base plate, you take heat away from heat generating components, you take it out of the power supply into your base plate, and then you can get the heat away from your base plate, which reduces the overall temperature of our power supply. Likewise, if you take an external fan and if you blow air across the components, the effectiveness of that cooling will be far better than conduction cooled, and it keeps the components cooler. So the result is an increase of the existing derating curve. Now, as I've previously described, here we have the ambient temperature starting at 0, going to 70, 10 degree steps. On the left hand side we have the load, and we have it in steps of 50 watts, 100 watts, 150 watts and 200 watts in this case. So if we apply either external cooling or if we apply base plate cooling, then the effect is we can increase the maximum ambient by where we can take that 200 watts power. So where does this line stop? Well, again, it goes back to my initial conversation, how cool can you keep the components? So this point here will be a direct function of the size of the base plate, for example, the effectiveness of the thermal resistance between the base plate and the power supply, or if you're using an external fan, what's typically measured is the cubic feet per minute or linear feet per minute, the amount of air that you can push across the components. And this is fully characterized on our data sheets.